When you hear Toto, you might think of cozy, high-tech toilets, but you'd never guess that this Japanese brand, which has been selling bathroom fixtures for over 100 years, recently saw its stock price surge 18% in a single day, hitting a 5-year high. The reason isn't better toilet sales, but their ceramic technology used in toilets, which has helped them break into the AI hardware supply chain. Even Samsung and Micron's memory chips rely on them. How did a toilet manufacturer transform into a new darling of the AI world? What is the ceramic black technology behind it all? Imagine the advanced manufacturing lines at TSMC. Besides using the most expensive EUV lithography machines to print nanometer-scale circuits onto wafers, engineers must use ultra-high temperature plasma to etch the patterns. Crucially, the wafer must not shake at all, or if the etching is slightly misaligned, the entire wafer is scrapped, resulting in a loss of millions. If you use mechanical clamps, you'd scratch the wafer, so how do you keep it perfectly in place? The answer is the electrostatic chuck, ESC. It's like a high-tech ceramic magnet that, when powered, generates a strong electrostatic force, gripping the entire wafer evenly so it stays perfectly flat. Not only that, it can pump helium through the back to dissipate heat, keeping the wafer temperature controlled within 1 degree to ensure a perfect process. Hardest of all to imagine is that this incredible semiconductor tech comes from Japan's leading bathroom fixture company. From foundry giant TSMC to memory leader Samsung, these firms rely on their electrostatic chucks. So the question is, how did a toilet company pivot its skills into semiconductors? Back in the 1970s, Toto dominated the Japanese bathroom market. Their strength was mastering ceramics, from raw material formulas to high-temperature firing, with absolute precision. But then the oil crisis hit, the Japanese housing market cooled down, and the demand for bathroom fixtures became saturated. Toto's management couldn't just sit around. They couldn't rely on toilets forever and needed a high-profit business with no competition, much like how Hoya transitioned from lenses to photomasks. Thus, in 1984, Toto officially established its advanced ceramics division. They started with industrial parts, such as faucet valves and heaters, working their way up from small components. T's philosophy was pragmatic. Treat this process as a trial by fire, gradually transforming a workforce that only knew how to make toilets into engineering experts capable of handling precision machinery. Not long after, an opportunity to change their destiny arrived. At that time, the Japanese semiconductor industry was facing a major problem. As chips became increasingly precise, the traditional method of using mechanical clamps to hold wafers was no longer viable. The industry saw the emergence of a new technology called electrostatic chucks, which use electrostatic force to replace physical clamps. At the time, however, the technology was highly immature, with yields, reliability, and cost all being significant issues. Surprisingly, after studying it closely, T's engineers found a breakthrough, realizing that the key to the electrostatic chuck was their specialty, ceramic technology. Simply put, the structure of an electrostatic chuck is like a sandwich. The bottom is the base, the middle contains the electrodes for power, and the top layer is the ceramic responsible for generating static electricity. When the middle electrodes are connected to a high-voltage positive charge, the top ceramic surface becomes covered in electricity. This is where it gets interesting. The silicon wafer placed on the ceramic is conductive, so the negatively charged electrons inside rush to the bottom of the wafer, and the powerful electrostatic force clamps the wafer firmly onto the chuck. The principle is simple, but in reality, the top ceramic layer of the chuck must be extremely flat to ensure almost no gap between the wafer and the chuck. If there is too much air in between, the suction becomes too weak to hold it. This happened to be T's strength. Having started out making toilets, they had long since mastered the art of making ceramics extremely smooth. T's engineers directly upgraded this ceramic process, originally used for toilets, to develop the electrostatic chuck, eventually launching their own product in 1988. But do you think they became an overnight success and made a fortune? Not at all. For the next 30 years, this department was a massive money pit. After all, the semiconductor equipment market at the time was dominated by US giants like Applied Materials and Lam Research. These major companies typically bundled their own chucks with the machines they sold, making it nearly impossible for an outside supplier like T, which started out making toilets, to break into the core supply chain. Furthermore, even though T entered the market early and had top-tier technology, their reliance on manual production meant their yields constantly struggled at the 50% passing threshold. It wasn't until around 2020 that T applied automated and AI inspection systems to its electrostatic chuck production line, finally boosting its yield rate to 90% and starting to turn a steady profit. But what truly turned T's fortunes around was what followed. You might ask, what exactly is 3D NAND, and what does it have to do with electrostatic chucks? In fact, 3D NAND is the memory chip found in modern SSDs, and it's in a completely different league compared to traditional 2D NAND. Since 2D NAND is a planar structure, each etching process is shallow and fast, causing minimal wear on the electrostatic chuck. But as 2D planar technology hit its limits, 3D NAND emerged, with circuits starting to stack from 24 layers upward. By 2020, to maximize memory capacity, manufacturers like Samsung, SK Hynix, and Micron began stacking circuits like skyscrapers, reaching 200 or 300 layers and beyond. Consequently, the etching process needed to penetrate these massive stacks, resulting in significantly longer processing times and maximum plasma intensity. The wear on the underlying electrostatic chuck became many times greater than before, causing consumption rates to skyrocket. It transformed from an inconspicuous durable good into a high-frequency consumable, naturally driving demand through the roof. Then came the real turning point, the 2025 memory boom. Not only was HBM for AI computing in high demand, but the 3D NAND used for data storage and AI servers also faced severe shortages. As a result, the electrostatic chuck, the component that wears out the fastest during production, became a strategic asset, and with T's top-tier quality and optimized yield rates, they were perfectly positioned. T caught this wave of orders that fell from the sky. Not only did equipment giants like Applied Materials and Lam Research come back to embrace them, but major memory manufacturers like Samsung and Micron even bypassed equipment suppliers to work directly with T, fearing their production lines might stall due to excessive chuck wear. As a result, the advanced ceramics business that was once a money pit generated 67.4 billion yen in revenue in 2025 alone, a year-over-year increase of over 30%. Even more impressively, this division contributed more than half of T's total profits, officially surpassing their century-old toilet business to become the company's biggest profit engine. Seeing this, don't you think T's story shatters the myth that traditional industries are destined to be mere sidekicks in the AI era? After all, the media and stock market are currently obsessed with tech giants developing massive AI models and manufacturing chips, while traditional sectors like cement and plastics are seen as unable to reap the era's dividends and destined for obsolescence. But TSMC proved that if you master your core manufacturing process to the extreme, you can break into the AI supply chain and become that key player that holds the bottleneck. So, which traditional factories in Taiwan do you think might be hiding such low-profile, cutting-edge technology, with the potential to become hidden champions in the AI era? Feel free to leave a comment below.